Okay friends, we will continue our Fourier series. Here we are knowing that formula for the Fourier series. I will recall here a function f of x is defined in intervals c to c plus 2l with period 2l. Then its Fourier series expansion is f of x is equal to a0 divided by 2 plus summation n into cos of n pi x divided by l plus summation bn into sine of n pi x divided by l. This is our Fourier series expansion. This a0, an and bn, these are the Fourier coefficients. And how we are calculated this Fourier coefficient? a0 is equal to 1 divided by l integration over given interval c to c plus 2l f of x into dx, an equal to 1 divided by l c into c plus 2l f of x into cos of n pi x divided by l into dx, and bn equal to 1 divided by l c to c plus 2l f of x into sine of n pi x divided by l into dx. Now I will modify this formula in a little bit using given function is even and odd. Using this we can modify here this formula. Now to modify this, suppose I will take my function f of x is defined in interval minus l to plus l. Now if function is defined in this type of interval, then we can talk this function is even and odd if f of minus x is equal to f of x. This happens for all x in this interval, then we are saying that this f of x is even. And if f of minus x is equal to minus of f of x for all x in our given interval minus l to plus l, then we are saying that this f of x is odd. Again, if we are going through geometry is that if our given function this f of x is said to be even, then its geometry is f of x is even, then f of x is symmetric about y-axis. Means using graph of our function also we can check our function is even or odd. Again, if graph is symmetric about y-axis, then we will say that this is even function. And if f of x is antisymmetric or this shows symmetry about opposite quadrant, then we will say that this function is odd function. Then f of x is odd function. Then we will say that function f of x is odd. Again, we are knowing that property of integration if function is even or odd. If suppose my integration is minus l to plus l f of x into dx, and we are getting here integration, this integration is 0 if f of x is odd, and we are getting this integration as 2 into integration 0 to l f of x into dx if this f of x is even. Using this property, we will modify in our Fourier series expansion formula. Now in this modification, I will write here suppose my function f of x is periodic in interval minus l to l, again with period is 2l, then its Fourier series expansion we are knowing, then its Fourier series expansion f of x is a0 divided by 2 plus summation n into cos of n pi x divided by l plus summation bn into sine of n pi x divided by L. This is our Fourier series expansion. I will say now this is our equation number star. Here A0 is, we will find Fourier coefficient where A0 is equal to 1 divided by L integration minus L to L f of x into dx. Now this function is defined in this interval minus L to L. Therefore I will talk about this function is either even or odd. Now I will take suppose case here this function is even. If this is even, then we can write this formula as 2 divided by L integration 0 to L f of x into dx. Means I can modify this a0 as directly in this way, 2 divided by L integration 0 to L f of x into dx. And if I will say suppose this is odd, if given function f of x is odd, then directly we are getting a0 equal to 0. Means using property of integration for this even or odd function, I will modify in our formula, and we are getting a0 is equal to 0 if this is odd, and we are getting f of x, so we are getting 2 divided by into 0 to L f of x into dx if this is even. In similar way, we can modify for this an also. An equal to 1 divided by L integration minus L to L f of x into dx, f of x into cos of n pi x divided by L into dx. Now this is even, this is again even. If I will say this is even, we are knowing that cos function is even, total becomes even. Therefore we will get this formula as 2 divided by L integration 0 to L f of x into cos of n pi x divided by L into dx. Again, if we will say that this is odd, then this total function becomes odd, and we are getting directly this is equal to 0 if this f of x is odd. Means f of x is odd, we are getting our formula in this way. And bn equal to 1 divided by L integration minus L to L f of x into sine of n pi x divided by L into dx. Now I will say this is even. If this is even but this total function is odd, this sine function is odd, this is odd, therefore total becomes odd, and we are getting this integration at 0. And if I will say that this is odd, then this is odd, this is odd, we are getting this is odd into odd, this becomes even. 2 divided by L integration 0 to L f of x into sine of n pi x divided by L into dx. Now this is formula we are getting if this is even, and we are getting this is odd. Means we can modify our Fourier series expansion if function is even or odd. Now I will write here formula directly if our function is even or odd using this property. Means I will write here number 1, if f of x is even in interval minus L to plus L with period 2L, then its Fourier series f of x is equal to a0 divided by 2 plus summation n into cos of n pi x divided by L. And again we are knowing that if this is even, then bn becomes 0, where this bn equal to 0 for all n. And a0 we can write 2 divided by L 0 to L f of x into dx, and an I can modify 2 divided by L integration 0 to L f of x into cos of n pi x divided by L. Calculating these values and putting in our this formula, we are getting Fourier series expansion for even function. Similar way I can write here, if f of x is odd in this minus L to plus L interval with period 2L, then we can write here, if this is odd, then A0 equal to 0 and An equal to 0. This N equal to 0 for all n. Then our Fourier series is only summation Bn into sine of n pi x divided by n. N equal to 1 to infinity. And how we can write Bn? Bn is equal to 2 divided by L integration 0 to L f of x into sine of n pi x divided by L into dx. Means here only using property of our function is even or odd in given interval minus L to plus L, we can write our Fourier series expansion. Means we can modify our basic formula of Fourier series expansion. Only keep in mind, if our function is even, if this is even, then we can write directly this Bn equal to 0, and our series Fourier series expansion is a0 divided by 2 plus summation n into cos of n pi x divided by L. And we can write corresponding formulas for a0 and Bn. If this is odd in this interval, then this a0 is 0 and n is 0 for all n, and we can modify our function f of x in this way, Fourier series. Okay, we'll cover one problem based on this. Now my example is here. Suppose this function is defined pi square minus x square in interval minus pi to pi, and this condition is given. This condition shows that this is periodic. This is period with period 2 pi. Now I will first of all check, given interval is here minus pi to pi. This is my interval minus pi to pi. Therefore I can talk this function is either even or odd. I'll check this function is even or odd by, as per our definition, f of minus x is equal to pi square minus, I am replacing x by minus x, and this is our function f of x. I will write here minus x whole square. This is nothing but pi square minus x whole square is x square, and we are getting f of x. This whole for all x in interval minus pi to pi. That means f of minus x is equal to f of x. Therefore f of x is even. If I will plot graph of this function, this graph shows this is pi square minus x square. Therefore x is equal to 0, we are getting this is pi square, and this is parabola. Here is pi, here is minus pi. We are getting graph here in this way. And again we are knowing that this is symmetric about y-axis. This is our y-axis. This is x-axis. This is symmetric about this origin. This is symmetric about y-axis, means using this graph also we'll say that this is symmetric. Now I will take graph here up to this, because range is given, interval is given 0 to pi only. This is our graph up to this 0 to pi, and this is periodic, that's why it goes on repeating. This is given in minus pi to pi only. Now clearly we are knowing that our function is even function. Therefore we are knowing formula for even function. In even function, for finding Fourier series, Bn is equal to 0 for all n. Therefore our formula becomes f of x is equal to a0 divided by 2 plus summation n into cos of n pi x divided by L. Now I will talk about L. What is L? Here period is 2 pi. It's 2 pi equal to L. 2 pi equal to 2L. This gives pi equal to L. And find here 2 pi is equal to 2L. Therefore pi is equal to L. I'll put L equal to pi in this formula. Therefore we get this is a0 divided by 2 plus summation n into cos of, now I am putting L is equal to pi, therefore pi get cancelled. This is nx. This is our Fourier series expansion. This is our final result. Only we have to find out this a0 and an. Now I will calculate a0 and an. a0 is equal to, now I will write directly formula 2 divided by L integration 0 to L f of x into dx. What is L? L is pi. 2 divided by pi integration 0 to pi f of x is our pi square minus x square into dx. This is equal to 2 divided by pi integration is pi square x minus x cube divided by 3 between limit 0 to pi. If we are finding here limit, then we will get this is equal to 2 divided by pi. I will find upper limit minus lower limit. This is pi square and this is pi into pi minus pi cube divided by 3. This is your upper limit minus lower limit x is 0 minus 0. You are getting 2 divided by pi into pi cube minus pi cube divided by 3. This is nothing but 2 divided by pi. We are getting 2 pi cube divided by 3. Here subtraction. This is nothing but our a0 is this pi get cancelled. 4 pi square divided by 3 is our a0. Now we will find an. An is equal to 2 divided by L 0 to L f of x into cos of n pi x divided by L, and we are knowing our L is pi. We will write here 2 divided by pi integration 0 to pi f of x is pi square minus x square into cos of nx. I am putting L is equal to pi into dx. Now to solve this integration, this total is our polynomial function. Therefore I will use here integration for finding polynomial function as I will write here in this way. 2 divided by pi, I will write integration. I will keep this function. We are knowing that this, if this is polynomial, then we have to write here first of all pi square minus x square as it is into integration of this is sine of nx divided by n. Then minus, we have to write derivative of this function here. This is pi square is 0 minus 2x into minus cos of nx divided by n and this n square. Now plus derivative of this function is 2 into again integration of this function is minus sine of nx divided by n cube. I'll close bracket between limit 0 to pi. Between limit 0 to pi. Now here I will put upper limit and lower limit. 2 divided by pi. In first bracket I will put upper limit 0 to pi. Now if I am putting pi here, this pi square, now x is equal to pi, pi square minus pi square get cancelled and this becomes 0. Here I am putting pi, this becomes 0. Now minus, now this is minus, this is minus, this is minus, total minus minus plus and this minus minus. Now here is I am putting pi, this is 2 pi cos of n pi divided by n square. I am putting x is equal to pi minus 2 into sine of n pi divided by n cube. This is your upper limit minus lower limit. Again I will put x is equal to 0. Now I am putting x equal to 0 for this bracket. We are getting pi square and here is sine of 0. Sine 0 becomes 0. Therefore this total term becomes 0 minus. Now again here this is minus minus minus, total becomes minus. I am keeping here minus sign and x is 0, therefore this total term becomes 0. I am putting x equal to 0 minus 2 into again here x is equal to 0, sine 0 becomes 0, means lower limit becomes 0. We are getting here this as 2 divided by pi into this is minus 2 pi cos n pi. What is cos n pi? Cos n pi is equal to minus 1 raised to power n. Therefore I will write here minus 2 pi into minus 1 raised to power. I will write here this as minus 1 raised to power n divided by n square, this n square, minus sine n pi is 0, and we are getting here an as 2 divided by pi into minus 2 pi into minus 1 raised to n divided by n square. Again I will rewrite this pi get cancelled. We are getting here minus 4 minus 1 raised to n divided by n square. This is our an. This is for all n. We are getting an is equal to minus 4 minus 1 raised to n divided by n square. Now I will put this value in our equation star. This is our equation star. I will write here a0 and an, then we will get here f of x. Therefore Fourier series is f of x equal to a0. What is a0? A0 we have calculated here. Now we are getting a0 is 4 pi square divided by 3. I will write here a0. And we have to write here a0 divided by 2. 4 pi square divided by 3 into 2 I will write, because this is a0 divided by 2 here, total term a0 divided by 2 plus summation an. What is an? This is minus 4 minus 1 raised to n divided by n square into cos of nx, cos of nx, and this is our total Fourier series expansion, or I will write here this is 2 pi square divided by 3 plus summation n equal to 1 to infinity. I can take minus 4 common also, but I will keep here. This is minus 4, or I will write here minus 1 raised to power n plus 1 divided by n square into cos of nx, and this is our f of x. What is f of x? This is pi square minus x square, and this is our Fourier series expansion of given function f pi square minus x square. Now our problem is over. Now I will modify this result and we'll try to find out some interested part. This is our Fourier series expansion of pi square minus x square defined in interval minus pi to pi. Now here suppose I will put x equal to 0, then I will check what will happen. Now this becomes pi square x is 0 minus 0 is equal to 2 pi square divided by 3 plus summation n equal to 1 to infinity 4 into minus 1 raised to n plus 1 divided by n square and cos of 0. Cos of 0 is 1. We are getting this series. I will write now this series as this is pi square is equal to 2 pi square divided by 3 plus, now I will put n equal to 1. If I am putting n equal to 1, this become 4 into minus raised to power n plus 1. N is 1, means 1 plus 1 is 2. Minus 1 raised to power is 2. This is plus 1, means we are getting 4 only. 4 divided by this is 1 square plus, I will put n equal to 2, because this series start from n equal to 1, 2, 3 and so on. N equal to 2 I will put here. 2 plus 1 is 3. Minus 1 raised to power 3 is minus in sign. I will write here minus 4 divided by 2 square. Then next n equal to 3 I will put. 3 plus 1 is 4. This becomes we are getting plus 4 divided by 3 square minus 4 divided by 4 square, and we are getting all these terms in plus or minus sign. Now I will take this term to this side. We will write here pi square minus 2 pi square divided by 3 is equal to, this is 4 is common here. I will write here 4 divided by 1 square minus 4 divided by 2 square plus 4 divided by 3 square minus 4 divided by 4 square and so on terms. I will write this as, this is here 3 pi square minus 2 pi square, means we are getting this is pi square divided by 3, which is equal to, shall I take 4 common? 1 divided by 1 square minus 1 divided by 2 square plus 1 divided by 3 square minus 1 divided by 4 square and so on terms. I will take 4 to this side, and we are getting here 4 I am taking to this side. That means we will get pi square divided by 12 is equal to 1 divided by 1 square minus 1 divided by 2 square plus 1 divided by 3 square minus 1 divided by 4 square and so on. Now this is interested series we are getting here. This is pi square divided by 12. Pi square is irrational number. This is pi square divided by 12. We can write in terms of series form. And this is reduction because of Fourier series expansion. Again, in this expansion, I will write this is your 1. Again, in this expansion of this Fourier series from our given problem of pi square minus x square, I will put x is equal to pi. Then we will check what will happen. Now put x equal to pi. I will check what will happen here. In this expansion, I will put x is equal to pi. Here, I will put x is equal to pi in this final answer, and then I will write what will happen. I will write here. This is our answer, pi square. This is our Fourier series expansion. In this, I will put x is equal to pi. Then this is pi square minus pi square, because I am putting x is equal to pi, which is equal to 2 pi square divided by 3 plus summation 4 minus 1 raised to n plus 1 divided by n square. This is cos of n pi, because I am putting x is equal to pi. Therefore, I have to put x is equal to pi here. This is nothing but 2 pi square divided by 3. This is 0 plus summation 4 into minus 1 raised to n plus 1 divided by n square. Now cos of n pi is minus 1 raised to n. This total becomes 2 pi square divided by 3 plus summation 4 divided by n square. I will write this is minus 1 raised to power n. I will split up in this way. Minus 1 and minus 1 raised to n. Total becomes minus 1 raised to n plus 1 into this minus 1 raised to n. I will keep as it is. Now this is minus 1 raised to n. This is minus 1 raised to n. We are getting minus 1 raised to power 2n. And this becomes only this converted here. I will write